Hey everyone, welcome to this explainer. I am absolutely thrilled you're tuning in today because we are literally looking at the most profound shift in software engineering since the introduction of high-level programming languages. The whole era of typing out syntax line by line, agonizing over semicolons, it's ending. Today, we're going to explore how software development is fundamentally shifting from typing code to expressing intent, and what that actually means for you and your teams moving forward. Okay, so let's jump right into this with a pretty staggering projection. By 2026, 41% of all new code is going to be AI generated. This proves that the shift we're talking about, it isn't some distant sci-fi fantasy. The foundation is being laid as we speak. In fact, 85% of professional developers are already regularly using AI coding agents. The machine is stepping up to handle the implementation, leaving the human to provide the judgment. To wrap our heads around all this, we're going to break this massive industry shift into 5 parts. The shift to intent, vibe versus agentic engineering, the AI factory and harness, conductors and orchestrators, and finally, the economics of AI.
All right, section 1, the shift to intent, moving from how to build to what to build.
Just think back for a second to the rapid evolution we've seen over just the last few years. Back in 2021, we basically just had autocomplete. Simple token prediction where your editor just guessed your next few characters. Then we got inline suggestions, and soon after, chat-based generation, where you could describe a feature and get a working implementation. But look ahead to 2025 and 2026. We are looking at fully autonomous agents. These agents run their own loops. They can clone repos, plan multi-file changes, execute them in sandboxed environments, run the tests, and even submit pull requests, all without a human typing a single line of code. The ceiling on what one single engineer can accomplish has just exploded.
Moving on to section 2, vibe versus agentic engineering. Let's look at the spectrum of AI-assisted coding.
Now, with all this incredible new power comes a really interesting tension. You've probably heard the term vibe coding, going viral online. It's when you just throw casual prompts at the AI, see what it spits back, and basically ask, does it seem to work? And hey, it's awesome for weekend prototypes or disposable code. But, and this is a big but, if you tell your CTO you're vibe coding the company's payment processing system, yeah, alarm bells are going to ring, and they absolutely should. Because for production systems at scale, you need what's called agentic engineering. This means formal specs, automated evaluations, and strict CI/CD gates. The biggest differentiator today isn't whether or not you use AI, it's how rigorously you verify the AI's output.
So the crucial takeaway here is that moving to disciplined agentic engineering requires a totally new skill. It's called context engineering. AI models don't just need a clever prompt. They need the exact same rich, deep context a human developer would need to do the job right. You have to provide these 6 specific types of structured info to your agent. You've got to give it instructions for its role and goals, domain knowledge like architecture diagrams, memory for its persistent state, specific examples of reference patterns, the actual tools and APIs it can use, and of course, strict guardrails. You are the one defining the boundaries.
But here's the catch. You can't just blindly dump all that information into the AI at once. To scale this without burning through cache, developers really have to master the architectural trade-off between static and dynamic context. Static context is always loaded. Think core rules and global memory. It's super reliable, but it is incredibly expensive in terms of token costs because you're paying for it in every single interaction. Dynamic context, on the other hand, is loaded strictly on demand, like specific agent skills or retrieved documents. It's incredibly efficient. Deciding what information goes into which bucket is a first-class architectural decision you have to make now. Which brings us to section 3, the AI factory and harness, building the system that builds the software. In this new factory model, the traditional software development lifecycle completely collapses. We're talking iteration cycles dropping from weeks down to literally minutes. The modern developer isn't just manually assembling code anymore. They're designing the factory that produces it. The AI knocks out the implementation incredibly fast. But notice what happens to the workflow. The human bottleneck shifts. It moves entirely to specification quality, architectural judgment, and verifying that output. You're no longer waiting around for human hands to type boilerplate. You're relying on human minds to define the boundaries and maintain quality control. To make this kind of abstract orchestration a bit more tangible, you really have to understand the concept of the harness. It's so tempting to think the AI model itself is the entire system. But think of the AI model as just the raw engine of a car. Now, an engine sitting by itself isn't going to get you to the grocery store, right? The harness is the car itself. It's the steering wheel, the road, and the traffic laws keeping the whole trip safe. It's the essential scaffolding that makes the model actually capable of finishing a task. If there is one equation you absolutely need to remember from this explainer, make it this one. Agent equals model plus harness. Because these 6 components, from the execution sandboxes all the way to observability and tracing, they govern roughly 90% of the actual behavior you experience when building software with AI. Honestly, when an agent fails, it is very rarely the model's fault. It's almost always a missing tool or some vague rules sitting right there in the harness. All right, Section 4, Conductors and Orchestrators. Let's talk about the developer's new role. Since AI is taking over the raw typing, your day-to-day role evolves pretty significantly. We're seeing developers fluidly shifting between 2 totally distinct modes of operating. You act as a conductor when you're working in real time, right there in your IDE, guiding an AI pair programmer with keystroke-level control and getting that immediate feedback. But then, you become an orchestrator when you zoom out, assign high-level goals, and delegate massive multi-file migrations to background agents that just work asynchronously. Both modes are totally vital, but they require a completely different set of skills. And knowing exactly when to play the conductor and when to be the orchestrator is the absolute key to solving what's known as the 80% problem. AI is fantastic, like truly mind-blowing, at rapidly generating about 80% of a feature. But that remaining 20%, the weird edge cases, the complex integration points, the highly specific business logic, that still demands deep human contextual knowledge. The absolute best developers don't just blindly accept everything the AI spits out just to move fast. They let the AI handle the bulk implementation, and then they hyper-focus their deep expertise on that critical final 20%. Finally, Section 5, the economics of AI. Let's dig into the hidden costs of token burn. We really have to pivot from technical architecture to the hard business reality for a second, because engineering leaders have to ask themselves, what is the true total cost of ownership here? Like, what are the hidden financial and operational burdens of just letting your entire team casually vibe code large systems day after day? Well, here's the reality check. Vibe coding feels incredibly cheap on day one. The barrier to entry is basically zero. But over time, it creates this massive operational expense, a really high OpEx. You end up trapped in these expensive prompting loops, just burning through API tokens while the AI tries to fix unstructured, unverified code. It leaves you with a mountain of maintenance debt. Agentic engineering completely flips this dynamic. Yes, it requires a high upfront capital expenditure, a high CapEx, because you have to deliberately build the harness, the API schemas, and the test suites. But once that factory is built, you unlock incredibly cheap, highly sustainable scale with incredibly low marginal costs per feature. I want to leave you with this final, highly provocative thought from the source material to really chew on. Generation is solved. Verification, judgment, and direction are the new craft. As the machines take on the actual typing and the rote implementation of software, the human role isn't diminishing at all. It's elevating. So the question is, how will you and your team master this brand new craft of judgment? Thank you so much for hanging out with me for this explainer, and I really hope this helps you build better, far more reliable systems in this crazy new age of AI.